Hello class, welcome to 6.6, divide polynomials. Divide each polynomial by a monomial. So this is a very simple limited topic, and we're looking at the first question. Find the quotient 7y squared plus 21 all over 7. So clearly this is a question that's asking us to divide. On the numerator we have a binomial. It's a polynomial, but binomial is a special case of it. And the denominator is a monomial. In all the problems in this section, we will only focus on denominators that are monomials, a single term. Okay. 7y squared plus 21 over 7. Now, in order to divide this, with regular numbers, we used to do long division, right? But here we're trying to look at the idea of LCD. Okay, I'm going to show that by the side here. Let's say x over 3 plus, let's say 5 over 3, right? If you had a problem like this, where you had to add two fractions, the first thing you would do is to see the denominators. If they are alike, if they are same, then you have no problem in simply combining the numerators and keeping a single denominator. That's the common one, right? So we are basically trying to do the reverse of this. In other words, if I say, let me use a different example. If I have y minus 4 over 9, then we could split this up as y over 9 minus 4 over 9, isn't it? I'm doing the reverse of what I just did previously. In other words, the 9 can be given individually to the y and the 4 with a minus in between, because if you took the LCD, which is common here, so you just take the common 9, you simply combine the numerators y minus 4. That's the same idea we're planning to use here. So 7y squared plus 21 all over 7 would be 7y squared over 7 plus 21 over 7. We are taking the division, the fraction, into separate fractions. The single fraction, we're splitting it into two separate fractions, each carrying the same denominator, 7. Now it's easy for us to simplify because you can see here that the 7 and the 7 will cancel each other off. 7 times 1 and 7 times 3. So just like that, your problem simplifies to y squared plus 3. That's your answer. So we divided the given polynomial by a monomial to get this quotient y squared plus 3. What about this? Well, they have this division symbol here. So I would like to write this out as a division bar as all over 6x. I know it's all over 6x because the parentheses for the numerator contains both the terms. That has grouped both the terms, so I know that the 6x divides the entire numerator. Okay, if not for the parentheses, then it would mean that the 36x squared is the only term that gets divided by 6x. Okay, so please understand the importance of parentheses. As we can see over and over again, it gives us big clues, clear information on how to handle the problem. Okay, let's separate this as 18x cubed all over 6x minus 36x squared all over 6x. All right, now we can handle them individually. Now we're looking at the numbers in the first fraction and the x's. The numbers can be simplified and the x's can also be combined using the properties. So with numbers, I can cancel it off as 6 times 1 and 6 times 3. So 3 is what I get out of the numbers, but with the letters, the bigger power is on the top, so I have to do 3 minus 1. Remember, it's quotient rule because you're dividing. Therefore, you will subtract the powers. Then I come to the other one. 6 times 1 is 6. 6 times 6 is 36. So I have 6x power 2 minus 1. 1 because the x takes the power 1 when the power is not explicitly written. Then we have 3x squared minus 6x. This is what it simplifies into, and that becomes our answer. Let's take a look at the next one. 12d squared minus 16d all over negative 4. Okay. Remember that the denominator is negative 4, so each part of the numerator gets the negative 4 in the denominator. There is a minus in between them. Let that be negative 4. Okay. Now we will handle the negative 4. 4 times 1 is 4. 4 times 3. So I get a 3d squared over negative 1 minus, let's come over here, 4 times 1 is 4. 4 times 4 is 16. So negative 4d over negative 1. Okay. Now it's time to combine the signs. So that's nothing but a negative 3d squared. There's a negative out here, and then there's a negative in the denominator. The negatives become positive, because negative over negative is positive. And that you have 4d. And that is our answer. Again, because we are arranging by descending order of powers, you will keep this order. Okay, otherwise, you would move them around. With that, we've come to the end of this section. I hope you enjoyed this short and light section. See you in the next one.